Hello everybody, I'm Storm here. Welcome back to Factorio. In the last episode, we got production set up for our bronze plate, our brass plate, and our solder coils. So, that's all running, all of the belts are in, everything is moving where it's supposed to. So yeah, that is working pretty well. So now we have a few more things that we need to make. We kind of sorted out here. Need to make silver. We need to make aluminum. We're going to need to make some glass, some invar, and gunmetal. And I now realize that there's probably some math issues, but we'll figure it out because there's going to be some low priority stuff. Like invar, we want to have some of that, but I don't think there's any like real production lines that are going to be using it, though it might. Gunmetal, like that's going to be used in the military production, but then that's a low priority. So we only want to be feeding gunmetal when nothing else is running. So we'll sort that out. I'll have to figure out like which of the processes, which of these items do we want to kind of borrow from for that, but we'll sort that out. Alright, but we need to do some math. There's going to be a lot of kind of mathing and design work again in this episode, so kind of where we're at. Alright, so I'll start with silver. We're making silver plate. So we'll need molten silver. This should be fairly straightforward. Silver ingots. We only have one recipe for silver ingots. So actually, that is very, very straightforward. How much silver ore are we producing? We're producing 4.7 per second silver ore. So, if we compute by factory, if we had one of these, 1.5, so if we have 3 of these, 4.5, that will work. We'll make 4.5 per second plate. Perfect. Alright, aluminum. Aluminum, again, we only have one recipe for that. We only have one recipe for this. This is going to be a little bit more complicated. We're going to need carbon, which, you know, we know how to make carbon. Make it from coke and steam. And alumina. We only have one recipe. To make alumina, we need aluminum hydroxide. This should be a 2. We need aluminum ore and sodium hydroxide. We are definitely making sodium hydroxide. The question is, how much? Now I wish I had all of my other processes set up, because we'll have to figure out how much sodium hydroxide we're making. Alright, well, how much can we make aluminum? You have 8 per second aluminum ore being generated. So if we compute by factory, 8 per second, so I guess we could do, what, 4 of those? Because 6 of those is too much. Well, I guess we could scale it to 6. We won't be able to feed it that much, but that'll allow us to squeeze the most potential out of it. Okay. So, 2.3 per second sodium hydroxide. what is the process where we're making sodium hydroxide? Out of curiosity. Salt loading, lime loading, sodium hydroxide loading. Is a process where we are electrolyzing saline water as part of the process to make hydrochloric acid. We could let this run. Let's see, we have two electrolyzers. Two electrolyzers. That are making it. How many electrolyzers will we need if we are electrolyzing saline water? We would need 5 electrolyzers. I see. Okay, and how much saline water will we need to produce? Water purification. We could use washing plants to make saline water. That makes tons of saline water. I see. If we were doing water purification, we would need 12 of them. 1,600 water. Ouch. Well, maybe we'll need to make this with our own process here. We need... I think we have washing plant 2s, don't we? Light mud water. Concentrated mud water. Heavy mud water. Viscous mud water. Yeesh. Okay. Oh, these are all 1s. 2s. 2s. I mean, there's still 3 of them. And, how many pumps would I need? 1 C4 pump. Okay. And that produces a lot of mud as a byproduct. We could turn that mud into landfill. That's not a problem. Alright. Now the question is, that mud water. I'd have to pipe it in, probably from down here. So there just isn't anywhere else that we could get it. I mean, it's not impossible. I've piped stuff further. Okay, then. Oh, they run into a wall of fire over there. Alright, well, let's just look at the other this is probably what we're going to be doing, but let's just look at our other production processes just to make sure that we don't have to do anything else. Alright. Glass mixture. We only have one option for glass mixture, and that's from silicon ore. Uh-huh. Alright, well, we'll have to route over some silicon ore. That'll be it. And Invar. Invar is a steel nickel. Steel and nickel alloy. We're gonna make as much of that as we can. Like, I think... Eight? 9? 10. That can supply 9? One induction furnace can supply 9 of those. Well, that's what we'll scale it to basically crank out as much of it as we can. There's no way we're going to be able to feed it this much. And it's a low priority anyway, so... we'll have to sort that out. Alright, gunmetal. Gunmetal is copper, tin, and zinc. Well, that works. Yeah, we'll go ahead and scale it to that as well. Really, I should do Invar and gunmetal first, because they're going to be the easiest. Gunmetal is going to be the absolute easiest. So, let's do that. An induction furnace and 9 casting machines. We'll probably just do 8, actually, not 9. That induction furnace is going to need 3 inputs. 1, 2. Three inputs. Oh, right. Keep the same systems in place. You're making molten gunmetal. Right. There we go. It needs copper, tin, and zinc. Alright. Here's tin. Here's copper and zinc. So what we'll do is we're going to split off of here. We're going to make sure that output priority is set there. that come out there. Alright, we're gonna do the same thing for zinc. Oh, right there. Output priority. Alright, and for zinc, or tin, same deal. Output priority is actually going to be left on this one. Alright. So, zinc comes here. Copper comes here. Tin goes there. Right, this is actually going to need to go underground. That's fine. Just throw those ingots in there. Alright, then we're going to use, what, 8 casting machines? Do I have casting machines on me? I do now. One, 2, 3, 4, 6, 7, 8. And as long as, you know, those are not being used for anything else, they'll go to make gunmetal. Alright. That's great. I'll get that done. Now, the other thing was in-bar. Again, same deal. Induction furnace. Well, we need 2 inputs. Only 2 inputs on this induction furnace. Molten Invar is what we're taking. And it's steel ingots and it's nickel, right? Yes. Steel and nickel. I can't remember, like, what was special about Invar. I think what makes Invar useful from an industrial perspective or a manufacturing and machining perspective is that Invar has a very low coefficient of thermal expansion. So it doesn't change size very much when subjected to heat and cold, which is very useful in precision machining that are going to be subjected to heat and cold. Just a bit of trivia there. I could be wrong about that. Because the other one is nitinol, and I think what that is, which is, I think that's a titanium nickel. Nitinol is a titanium. Now I'm curious. Nitinol is... Oh, nitinol is... It is a titanium nickel alloy. And I think that what is useful about that, or interesting about that, is that it has shape memory. Is that if you, like, heat it to its memory temperature, it will return to whatever shape you kind of... I'm not exactly sure how it works, but it will return to its... If you deform it, it'll return to its original shape if you raise it to a certain temperature. Alright. Steel ingots. I need to figure out how to get you where you need to be. Alright. Now again, this is low priority. Output is prioritizing to make steel sheet coils. All right, give me lots and lots of belts. All right. Because I think this is the line, right? This is the line that we were on. Right, that's coming out to here. Alright, there it goes. Now what I really should have done here is buffered this through a box. Could I still do so? Yeah, maybe. If I brought it up here... and I brought it back down here. You know what? Let's actually do that. Like, I should have done it with a bunch of different things, but we'll do that now. Like, I could do that over there with the manganese. Yeah, let's bring it up here. Let's throw it into a box. Throw it into a box. Pop it through there, and then we can come over here and split this off with the output priority set. Just like that. Now, nickel ingots. Where's our nickel, right? This is nickel, right? Nickel ingot. And we do have that buffered through a box. And the way I really need to do this is a different way. I don't think those nickel ingots are going anywhere else. Output priority left. Nothing else is sharing that belt in any case. How much room do I have to work here? Because we're going to be extending this. Not enough is the answer to that question. Not enough for that anyway. Alright, then what we'll have to do, we'll have to send the tin ingots underground for a second. Okay. So that we can bring nickel here. We're also going to have to bring a line of silicon ore through here at some point. Ooh, that's not going to work either, is it? Because we're going to have to go around signals? Are we going to have to go around signals? Not really. Though I probably should signal off some of this at some point. Alright, well, we're not going to worry about it right now. Alright. Here we go. Steel and nickel. I gotta figure out where we're gonna put those tin ingots. We'll put them in here. And you are making Invar. I'm gonna need some pipe. We got some pipe. How am I doing on medium electric poles? We're doing fine on electric poles. the offsets. Alright, very good. So we can get rid of those off the line. So now we just need to get... Well, silver is going to be easy. We need to run a line of silver ore through all of this at some point. We're going to need to run a line of aluminum ore through all this at some point. And we're going to need to run a line of silicon ore through all of this at some point. So I have to figure out how I'm going to make that work. We're just going to have to send stuff underground, I think, a little bit to make room. Right, because we've got a line through here where the sulfur dioxide gas is. I think we also have a line through here where this purified water line is. That has some room. For the moment, we can figure some stuff out. Yeah, it's gonna get tight. All right. Or here's probably the better option. We can run the lines along this side of the track. We have to figure out where all the loading bays are going to be, which is not hard. We could just, you know, do the blueprint and drop them in. That's probably actually the correct way that we're going to do this. Let's see. Here's the silicon. And then we have silver and aluminum. Yeah, that's the way we're going to do it. All right, but we're going to go ahead and stop here for now. And we will work on those projects next episode. So for now, I hope you guys enjoyed it. Thanks for watching. Go ahead and like, subscribe, and comment, and I will see you next time.